Today's lesson is 6.5, Apply Other Angle Relationships in Circles. We're going to go ahead and start out with a theorem that says if a tangent and a chord, intersect at a point on a circle, then the measures of each angle formed is 1/2 the measure of its intercepted arc. Let's go ahead and take a look at our picture. Here is our tangent because it's only touching our circle once. And here is our chord because it's not going through the center. And we can see that they are intercepting right here at point A. So this theorem says that the measure of angle 1 is 1/2 the intercepted arc of angle that angle 1 creates. That would be this arc right here from A to B, or from B to A. Likewise, the measure of angle 2 is going to be 1/2 of the arc that it makes, which is this arc right here. Oops. This arc right here, which is A to C to B. Oops. A to C to B. All right, let's go ahead and take a look at how this would look in a problem. Line M is a tangent in my picture, and AB is a chord. If we take a look at it, AB is a chord. Let's find the measure of angle X. So we can see on our picture that we have our tangent right here, line M, and of course we have our chord right there. So my theorem says the measure of angle X is 1/2 of the intercepted arc, which would be this one right here. Well, if you notice, AB is said to be 130 degrees. So all we have to do is say 1/2 times 130, or 130 divided by 2, which gives me 65 degrees. This would be my answer. Let's take a look at another way that you could see this problem. Here's a second circle, and they want us to find the measure of arc KJL. So let's go ahead and put that arc. Let's draw it. There it is. I'm noticing that here is my tangent. I know I used the same color. And here is my chord. And what I'm seeing is that the measure, if I use the theorem, the measure of angle KLM, which I know to be 125 degrees, is 1/2 of that arc KJL. So 125 degrees is 1/2 of the arc that I want to find. To find that arc, I'm going to multiply by 2 to get my arc alone, right? There's my arc. And what I do to one side in an equation, I do to the other. So I get 250 degrees. 2 times 125. So just notice the subtle difference. When I know the angle, I multiply by 2 to find the arc. When I know the arc, I divide by 2 to get the angle, or I multiply by 1/2, same thing. All right, let's take a look at another theorem. This theorem is called angles inside the circle theorem. If two chords intersect inside a circle, so here are my two chords, and they are intersecting inside my circle. They're intersecting right here. Let me make you so you can see that right there where they are intersecting. Then the measures of each angle is 1/2 the sum of the measures of the arcs intercepted by the angle. Take a look at angle 1. Let's take a look at angle 1. Angle 1 intercepts this arc here. Ooh, that was kind of big. Let me see. This arc here and this arc here. Okay, we're going to go crisscross across from it. So angle 1 does this arc and this arc. So to find the measure of angle 1, it is going to be 1/2 the measure of AB plus the measure of DC. Okay, it's going to take the two orange ones for angle 1. Now for angle 2, let me go ahead and change my color. For angle 2 is going to come down here and go up here. So it's going to be this arc and that arc for angle 2. So the measure of angle, there we go, angle 2 is half the measure of arc AD plus the measure of arc BC. Just notice that they're going across from the angle. So you take the angle and you go down and then you take its vertical, okay? Down, right across from it, and then it's a vertical. That's how I'm getting the two that pair up, okay? Let's go ahead and take a look at what this would look like in a problem. Find the values of x and y, JL and KM are, let's take a look, JL and KM, they are chords. They are chords. So this is exactly the theorem that we just saw. We just have to go through and we have to decide how to find x and how to find y. So x looks like it was in the 2 spot up above, so it's going to do this, and it's going to be this arc and that arc. So to find the measure of angle x, it's going to be 1/2 times 130 plus 156. That's how I'm going to find x. So 130 plus 156 is 286. And remember, half of 286 is the same as, that's the same as saying 286 and dividing it by 2. They're the same thing. And I get 143 degrees either way. Okay, then my other one, angle y, looks like angle 1 from up above. And so it's this arc and it's that arc. And let me see, to find the measure, ooh, no, it's way too big. To find the measure of angle y, it's going to be 1/2 39 plus 35. 39 plus 35 is 74. And remember, it's the same. You can think of it as 74 divided by 2, or you could do 74 times 1/2. Either way, we get 37 degrees. Okay, they're inside the angle. Our last theorem for today is the theorem called angles outside the circle theorem. So if a tangent and a secant, two tangents or two secants intersect outside a circle. Notice that both of my pictures, they're intersecting outside the circle, not inside the circle. Then the measures of the angle formed is 1/2 the difference of the measure of the intercepted arcs. Notice this time it's the difference. This time it's the difference. So let's go ahead and take a look at the first one. I have my secant and I have my tangent. Here's my tangent, right? And here's my secant. If I take the two pieces between A and B, they would be considered a chord, but the whole thing would be considered a secant because it's continuing through. Angle 1 says we're going to take the two arcs, the two intercepted arcs, which would be, oh, let's see, let's change the colors, which would be this arc and trying to think of a nice color that goes with my color scheme. I'm overthinking it, you guys. There we go. That doesn't look so bad. And that one. Okay. Now you have to do this in a specific order. So to find the measure of angle 1, it's going to be half the measure of arc BC. The outside goes first minus the measure of the inside arc, AC. So it's always got to be the outside minus the inside. It's always got to be the outside minus the inside. Even in my second one where I have two tangents, so in my second one, I have two tangents intersecting, right? There's tangent 1 and there's tangent 2 to create angle 2. I still have my inside right here and my outside arc right here. And to find the measure of angle 2, it's going to be half the measure of the outside, which is PQR, minus, this one's minus because they're outside, the measure of arc PR, the inside. Okay, so it's always the outside minus the inside. Okay, let's go ahead and take a look at our two arcs. Find XY. Notice I'm giving you some hints right here. I'm giving you some hints right here. Lines M, N, and N are tangents. So in my first one, these two are tangents. And in the second one, H and L are secants. Now, I know we didn't see this picture in the theorem up above, but the same holds true. It's the outside minus the inside. Okay, the outside minus the inside. So here we go. All right, let's take a look at our arc. This is, this is the angle they want us to find. Here is the inside arc, and here is the outside arc. Everything is measured for me. So to find the measure of angle X, it's going to be half 284 minus 76. 284 minus 76, which is 208. And remember, a half times 208 is just like dividing 208 by 2, which gives me 104 degrees. Okay, the same thing holds true in the second one. Here is the angle. Here is the angle, right? Notice they're telling me it's 30 degrees. Here is the inside. Here would be the outside. So this time, 30 equals half of y minus 44. If I go in the places that the other one is 30 minus half, my theorem for this one would say the measure of angle KJR equals half of FG minus KR. There we go. That would be our theorem if we were looking at it. Now, what I would do here is I would get rid of the fraction first by multiplying by 2, because I don't know about you guys. I don't want to deal with the fraction. And if I get rid of the fraction, I simply have y minus 44. And then I only have to add 44 to both sides. Man, that actually turned out really, really good. And I end up with 104. Now, are they always going to be the same? No, it just happened this time. That's it. See you guys next time.